What's up everybody and welcome to a new video. And in this video we continue to go over my notes for the built-in functions in Python. So then the next category that we're going to cover is here this iterables category. And here the first function is called len, and with that you can determine the length of a given iterable. So for example, to demonstrate that, I've prepared here this list and a string. So now if I then say here len of the list, then we get a 3 because there are 3 elements in the list. And if I say here len of the word, then we get here 5 because there are 5 characters in this string. So then, so that's the len function. Next we have then here the sum function. And as the name implies, with that you can simply determine the sum of an iterable that contains numbers. So therefore, let's use here this list. So then here, if I say sum of the list, then we get here 6 because those numbers here add up to 6. And then here also, what you have here for this sum function is an additional parameter, and this is this start parameter. And if I set this, for example, to 100, then here our sum is then 106. And now just as a side note, let's also see what happens if we pass in here an empty list. Namely, in that case, we get here a 0. So this is how this sum function works. Then the next functions are called min max, and with those you can determine the minimum or maximum value of a given iterable. So here I first want to cover the basic use of that. So therefore let's again use here our list. So then here if I say min of that list, then it returns back a 1 because that's the minimum value of this list. So this is how this works when you just use one argument, but you can also pass in here multiple arguments. So for example, if I say here min list and then comma, and then here I've prepared another list. Then if I run it like this, then it will use lexicographical order to determine which of these lists here is smaller. And if you don't know what it is, then I will put the link to the respective video into the video description. But now let's just run it here. So here you can see that we get back this list here. And that's because here this third element is smaller than the third element in this list. Okay, so that is the basic use of those functions. And then the next note here is about the default parameter. Namely, what that is useful for is the following. Namely, if I put in here an empty list, then we get back here a value error. So if you don't want that, then you can specify a value for this default parameter. So let's do that here. So now if I say here default, and let's set that equal to the string empty. So now if I run it like this, then it doesn't throw an error, but it returns here the string that says empty. Okay, so that's the default parameter. And then here the last note is about using those functions with a key function. So to demonstrate that, I've prepared here 2 lists. So here we have list 1 and list 2. List 1 contains 2 and 2, and list 2 contains 1 and 9. So now let's use the min function with those lists. So let's say here min of list 1 and then list 2. So if I run it like this, then we get back here list 2. And that's because the first element in this list is smaller than the first element in this list. So now let's use here this function with a key function. So therefore we use here the key parameter. And here we're going to use the sum function. So what this does is it will calculate the sum of those lists and then determine which of these lists here is smaller based on the sum. So now if I run this, then you can see that we get back here list 2, and that's because the sum of this list is smaller than the sum of this list. Okay, so this is how you can use the minimum function with a key function. And with the max function, obviously everything works the same. Only in that case, then you get back the maximum value. Then the next function is called sorted, and with that you can sort a given iterable. And here I also want to first cover the basic use of that. So therefore I've prepared here this list. So let me copy and paste that. So here we have the numbers 3, 1, 2. And now if I say here sorted and then list, then we get here our list sorted, and we have 1, 2, 3. And you can also do it in descending order. So therefore, let's say again you're sorted and then list, and then you simply need to use here this reverse parameter and set that to true. So then we have it in descending order 3, 2, and 1. And here just as a side note, the sorted function doesn't change our original list here. So for example, if I print that out again, then this is still not sorted. Okay, so that's basic use, and then you can also use it with a key function. So to demonstrate that, I've prepared here another list. So here we have a list with strings. So here we have a lowercase a, a capital Z, and a lowercase b. And now if I say here sorted and list, then you can see that a Z here is actually at the beginning, and that's because capital letters have a lower ordinal value than lowercase letters. So to get around that, we could use here a key function. So to do that, we can here again say sorted and the list. And then here for the key function, we could, for example, provide here this lower function. So what this does is then it lowers all those strings here, and then those values then are sorted based on the return value of this function. So if you run it like this, then you can see that the C here is actually listed at the end. And for this key function here, by the way, you could also use here a lambda function. Okay, so this is then how this sorted function works. Then the next function is called reversed, and with that you can simply reverse a given iterable. So therefore let's use here this list again. So if we say here reversed and then this list, then you can see that it actually here returns an iterator. So let's simply transform that here in the list to see what it looks like. So then here we get this list, and here, as you can see, here we get BCA. So this list here was reversed. So this is how this reverse function works. Then the next function is called filter, and with that you can filter a given iterable. And here I first want to cover the basic use of that. And to demonstrate that, I've prepared here this code snippet. So here we have a list which contains the numbers -2, -1, 0, and then 1 and 2. And then one thing that you might want to do is to only keep here the numbers that are below 0. So one way to do that would be here to create here this empty list. And then here we're going to loop over our list here and then say if the number is smaller than 0, then we want to append that number here to our negative numbers list. So then let's also print out this list here. And then you can see that we get that we only here have the numbers -2 and -1. So you can do the same thing here with this filter function. So therefore let's here simply say filter, and then let me open here the doc string. So here, as you can see, first you have to specify a function and then the iterable. So now let me just do that, and then afterwards I will explain what this function then does. So here I'm going to use a lambda function. And then I'm going to say x, and here I want to have the x that is smaller than 0, and then here we pass in our list. So now what this function then does is it will filter our list here to only keep the elements where this function here returns a true, i.e. it will only keep the elements or the numbers here that are smaller than 0. So now if I run this, however, then you can see that this actually returns an iterator. So let's again transform that into a list to see the result of that. And then here you can see that we also get here a list that contains -2 and -1. So that's the basic use of that. And then here, this other note states that when you use none as the filter, then this function filters for items that are truthy. And I've talked about something called truthiness in another video. So if you don't know what that is, then I will put a link to a respective video into the video description. But now let me just demonstrate what I mean by that. Namely, therefore, I've prepared here this list which contains some values, and now let's use here the filter function with this none to filter those lists here to only keep the truthy values. So therefore then we say here filter, and then here we pass in none and then our list, and then let's also again transform that into a list to see the actual result. And then here you can see that we only keep here the first 2 strings, hello world, because those other values here are considered falsy. Okay, so those are my notes for the filter function, and this is how this filter function works. Then the next function is called map, and this is very similar to this filter function. However, what this does is it maps or applies a function to every element in an iterable. So here I first again want to cover the basic use of that. So therefore I've prepared here this code snippet. So here again, we have the list with those numbers here, -2, -1, 0, 1, and 2. And then let's say that we want to create a list that contains the squares of those numbers. So therefore, one way we could do that is in this way here. So we create first here the squared numbers variable, which is an empty list. Then we loop over this list here, and then we simply append the number squared to our squared numbers list. So let's also print out those squared numbers here. And then here you can see that we get this list containing 4, 1, 0, 1, and 4. And we can do the same thing here with this map function. So therefore then we simply say map, And then again, we first pass in the function. So we're going to use again a lambda function. And here we're going to say x. And what we want is x squared. And then we pass in here our list. So now if I run it like this, then again, we get here an iterator. So let's therefore then transform it again into a list to see the actual result. So here you can see that we get here the same list. So that is the basic use of this map function. However, you can also use it with multiple iterables. So to demonstrate that, I've prepared here these two lists. So list 1 and list 2. List 1 contains the values 1 to 3 and list 2 contains the values 3 to 1. And now let's say that we want to add up the respective values in these two lists. So we want to add here this first value in list 1 with the first value in list 2. Then the second value in list 1 with the second value in list 2, and so on. So we can do that here with the map function and then use multiple iterables. So therefore then we say here map, and then again let's use here a lambda function, and here we're going to use then x and y, and what we want is x plus y, and then we pass in here our list 1 and then also our list 2. And then let's also again transform this into a list. And now if I run it, then you can see that we get here the list which contains here this 4, 4, and 4. So this is how this map function works. And then the last function here is called slice. And with that you can do slicing. And in another video I talked about slicing in more detail. So if you want to know more about that, then I will put the link to that video into the video description. But now let me just demonstrate how the slice function here works. So therefore I've prepared here this list which contains the numbers 0 to 9. And now let's use here the slice function to slice here this list. So to do that, we say here list and then brackets, and then here we can use the slice function. So then here, if I just pass in one argument, then this is used as the end of this slice. So if I run it like this, then we only get here the first 3 elements. However, we can also specify here multiple arguments. So we can say, for example, 3 and 9. Then this first element here is the start of the slice, and the second one here is the end. So if I run it like this, then we get here the numbers 3 to 8. And then here you can also specify a step size. So for example, if I set that to 2, then we get here the values 3, 5, and 7. So using the slice function is basically the same as using a slice notation. So for example, if I say here list and then 3 colon 9 colon 2, then we get here the same result. However, the advantage of using this slice function is that you can store it into a variable. So for example, if I say here slice 1, that should be equal to our slice here. And then let's put in here this variable into these brackets here. Then we get here the same result. So in this way, then you could use the slice multiple times throughout your program, which would not be possible here with this slice notation. Okay, so this is how this slice function works. And with that, now we've covered here all the built-in functions in this iterables category. Then the next category is called looping or iterating. And here the first function is called range. And with that, you can simply create a range that you can loop over. So for example, if I say here for I in range 3, and then here within this for loop, I'm simply printing out the I. So then if I run it like this, then here we created a range going from 0 to 2. And here, however, you can also specify a start and an end. So for example, if I say here 3 and 9, then the range looks like this, where we go here from the 3 to the 8. And here again, you can also specify a step size. So for example, if I set that to 2, then the range here only contains here 3, 5, and 7. And here you can also actually use a negative step size. So therefore then let's go here from 9 to 3. And if I run it like this, then the range contains here the values 9, 7, and 5. So this is how this range function works. Then the next function is called enumerate. And to demonstrate how that works, I've prepared here this list. So here this list contains the strings hello, world, and universe. And now let's say that we want to loop over this list and we want to get the actual value, but we also want to get the index of that respective value. So to achieve that without using this enumerate function, we would do the following. So we would say here for index in range and then length of our list. And then here we could then print the index. And then to get the respective value, we would say list brackets index. So if I run it like this, then we can see that here at index 0, we have the value or the word hello. At index 1, we have the word world. And at index 2, we have here then the string universe. And we can achieve the same thing in a more easier way with this enumerate function. So therefore, let's simply here say for element in enumerate and then list. And then here, let's simply print our element. So if I run it like this, then you can see that this enumerate function here returns here these tuplets where the first element is the index and the second element is the actual value. So then to get the respective index and value, we can do then here the following. So we can say for index, comma word in enumerate our list. And then here we can simply print the index and the word. So then here we get the same result that we had before with this for loop. So this is the basic use of this enumerate function. However, here there's also an optional parameter, and it's this start parameter. And with that, you can specify where the index here should start. So for example, if we set here the start parameter equal to 1, then the index here actually starts at 1 and not at 0. So this is how this enumerate function works. Then the next function is called zip. And here I first want to cover the basic use of that. So therefore I've prepared here these two lists. So here we have list 1 and list 2. And now let's say that we want to add up the respective elements of those lists. So we want to add here the first element of list 1 with the first element of list 2, and then the second element of list 1 with the second element of list 2, and so on. So we could also do that without using this zip function. So therefore then we would simply say for index in range of the length of list 1, for example. And then here, let's simply say print, and then we're going to say list 1, and then brackets index. And to that, then we simply add list 2, and then brackets index. So to get the respective values. So now if I run it like this, then we get here the result 5, 7, and 9. And this can be done more easily here with this zip function. So therefore, to show how that works, let's simply say here for element in zip. And then here we pass in the iterable, so list 1 and list 2. And then let's simply print out first here this element to see what that looks like. So if I run it like this, then you can see that we get here these tablets again, where the first element is the first element of the first iterable, and the second element here is then the first element of this second iterable here. Okay, so now we can use that to here print out the sum of those respective values. So therefore then here we simply say for num1 and then comma num2 in zip, and then here again list 1 and list 2, and then here we simply print num1 plus num2. And then if I run it like this, then we get here again the result with which is 5, 7, and 9. So that is the basic use of this zip function. And then here the next note is about the case when the iterables have different lengths. Namely, the default behavior in this case is that the iterable with the smallest number of elements determines how many iterations there are in the for loop. So to demonstrate that, I've prepared here these 3 lists, which have different lengths. And now if I say here for element in zip list 1, list 2, and list 3, and then print out here the element, then you can see that we only get here those 2 tuplets, and that's because the smallest iterable that we have here is list 3, which only has these 2 elements. So therefore then we only get here those 2 tuplets. So that's the default behavior. And then here there's also an alternative behavior which is when you set the strict parameter equal to true. So for example, if I set here then this strict parameter equal to true, then we get the following. Namely, those first two tuplets here are again printed out. However, then in the third iteration of this for loop, we then get here this value error because argument 3 is shorter than arguments 1 and 2. So here argument 3 is shorter than argument 1 and argument 2. Okay, so this is then how this zip function works. Then the next functions are called iter and next, or aiter and anext. And here I want to first cover the basic use. Namely, to show that, I've prepared here this list. So this simply contains the numbers 1 and 2. And now let's use here this iter function to transform this list here into an iterator. So therefore we simply say iter and then put in here our list. And then if I run this, then you can see that we get here an iterator. And an advantage of an iterator over a list, for example, is that iterators are generally more memory efficient. And this is especially true when you have a very large list. Okay, so now let's store here this iterator into a variable. So let's simply call this iterator. And then next, what you can do is you can use this next method to get the elements of the iterator. So for example, if I say then here next and then iterator, then if I run this, then you can see that we get here a 1 because that was the first element in our list. And then if I run it here again, then we get here a 2 because that was the second element. And then if I run it the third time, then we actually get here an error because there was no element anymore in our iterator. So in this case, then if you don't want to get an error, then you can also provide here a second argument. And let's make this here simply a string that says end. So if I run it like this, then we don't get an error, but instead this next function then returns here this end as the value. Okay, so that is the basic use. Then the next note here is about this callable and sentinel approach. Namely, if you look here at the docstring of this iter function, then you can see that we can also provide a callable and a sentinel. And in that case, then the callable is called until it returns the sentinel. So what it means is that for this callable, we can provide here a function, and then that function is called until it returns here a sentinel. And an example use case for that is if you would want to receive a list of inputs. So for example, in the previous video, we've covered this input function here. And with that, you can receive a singular input from a user. So now let's say that you actually want to have, or that you want to receive multiple inputs and then put them into a list. And you could do that here with this iter function. So for example, we then say here iter, then we first provide a callable, which is in our case, this input function. And then we provide a sentinel. So this value is then the value for which this callable is not called anymore. So for example, if we say here stop, so if you provide then, or if you type in here for our input function a stop, then this input function is not called anymore. Okay, so now to make sure that this is not here an iterator, but a list, let's transform this here then into a list. And now we can call this. So now when we call this, then this input function here is called, and we can provide here our input. So let's say simply hello and then enter. And when I press enter, then this function is again called. So now we can provide our next input. So we can say world. And if I press enter, then the function is again called. So now let's provide here the sentinel. So therefore we simply say here stop. And then the function is not called anymore. And then we get here this list, which contains here those two strings here, hello and world. So that is how this callable and sentinel approach works. And then here, the last note states that iter and anext are the asynchronous counterparts to iter and next. And this is a more advanced topic, which I'm not going to cover in this series. So this is then how this iter and next function, how those work. And with that, now we've covered here all the functions in this looping and iterating category. Then the next category is called checking. And with those functions, you can perform various checks. So for example, the first one here is called all. And with that, you can check if all the elements in an iterable are truthy. And again, we've covered truthiness in another video, so I will put the link to that video into the video description. So now let me just show how this function here works. So therefore, I've prepared here this string, which simply this list, which simply contains here those two strings, hello and world. So now let's use here this all. function on this list. And then if I run this, then we get here a true because all of these values in this list are truthy. And now, however, let's actually delete here the second string. So let's make this here an empty string. And if I run it like this, then we get here false because an empty string is to be considered falsy. And then another thing that I want to show here is this edge case where we provide here an empty list. Namely, in that case, then we get here a true. So this is how the OR function works. And now let's do the same thing here with the any function. So this simply checks if any of the values in an iterable are truthy. So therefore then, if we use it here, we then also get here true because at least one value here in this list is true. And then here, however, where we got a false with the OR, if we use here any with that, then we get here actually true because here this hello string is considered to be truthy. And then here for this edge case, however, if we use any here, then we actually get here a false. So this is how all and any work. And then the next function is called callable. And with that, you can simply check if the given Python object is callable. So for example, if I say here callable and then simply provide a string, so a string that says hello, then if I run it like this, then we get a false because the string here is not callable. However, if I say here hello and then dot lower, so if I access this lower method, then this is actually callable. So that's why then we get here true. And now I just want to show some more examples. So for example, if I put in here this function, the string function, this built-in string function, then this is also callable. And what you also can do is, for example, use lambda functions. So here, if I say lambda x, and then this should simply return the x, this is also callable. And then here I've also provided some example code where we define a function and a class. So if I then run it here, if I say callable and then my function, this is also callable. Or if you check here this class, so if you say callable and then put in my class, then this is also callable. So this is how this callable function works. And then the last function is called isinstance, and this checks if the given Python object is an instance of a particular class. So for example, if I say here is instance, and then here you first provide the Python object that you want to check. So for example, let's provide here a string that says hello, and then as the second argument, you provide then the particular class. So for example, let's use here an integer. So what this then here checks is if this string here is an instance of the class integer. And since that's not the case, we then get here this false. So that's one way of using this instance function. Another way would be the following. So here, instead of just providing one class, you can actually provide multiple classes by putting them into a tuple. So for example, if I then say here int and then comma string, so then what this does is it checks if this string here is either an instance of an integer or a string. And since that's the case, then therefore then we get here this true. So this is how this isinstance function works. And with that, now we've covered here all the functions in this checking category. Then the next category contains functions related to classes. So we will talk about classes in a later video. So therefore, let me just here show how these functions work. So this first one is called setAttribute, and with that then we can simply set an attribute for a given instance. So for example, here then I want to first cover the basic use of that. So therefore I've prepared here this class. So this is simply called my class, and then here I'm creating an instance of that class. So now let's set an attribute for this instance here. So therefore then we use here this setAttribute function. Then first we will provide the instance, then the name of the attribute. So let's name this x, and then the value for that attribute. So let's make this a 1. And then if I run this and then say here instance.x, then you can see that this x here was created and has the value 1. So using this setAttribute function is basically the same as using this basic notation where you say here instance.y equals 2. So this then also creates then here this attribute. So that's the basic use of this function. And then here there's also some, I also want to cover some potential use case. Namely, therefore I've prepared here this code snippet. So here I've created a list with attributes, which are simply called A, B, and C. And now we can use this setAttribute method to create all of these attributes here in this list. So therefore we simply loop over the list and then here use this setAttribute method. So now if I run this and then say here instance and then A, then you can see that this is 0. I say here instance.b, then we have the 1. And if I say instance.c, then we get here the 2. So this is something that you couldn't do here with this basic notation. And therefore then that would be an advantage of using this setAttribute function. So this is how this setAttribute function works. Then the next function is called hasattr, and with that you can check if the given instance has a certain attribute. So for example, to show that, I've prepared here this class. So here I simply created here this attribute, and then here I'm creating an instance of that class. And now if I say hasattr, and then here I first provide again the instance, and then the respective attribute that I want to check. So for example, if I put in here an x, then we get a true because our class has here an attribute called x. However, if I, for example, say here y, then we don't get, then we get a false here because our class here doesn't have an attribute that is called y. So this is how this hasattr function works. Then the next function is called getattr, and with that you can get the value that is associated with a given attribute. So to demonstrate that, let's again use here this class. So therefore then here, let's say getattr, and then here again we first put in our instance, and then the attribute that we want to get the value for. So for example, let's say here put in then the x. So then this returns then here this 1 because the value of x is 1. So using this function here is basically the same as saying instance.x, because here then we also get here this value for this attribute x. However, there's one difference here with this function, and the difference is when this attribute here doesn't exist. So for example, if I say here get attribute for the attribute y, then we get here an attribute error. So this is actually the same as if we would use here this basic notation and then here say instance.y. Here we also get an attribute error. However, for this getAttribute function here, we can actually provide here a third argument, and this third argument is then the value that this function returns in case this attribute here doesn't exist. So for example, let's make this here a string that says doesn't exist, and then we don't get here an error, but instead it simply returns here that value that we have here provided. So this is how this getAttribute function works. So then the next function is called deleteAttribute, and with that you can delete instance attributes. And here I want to first cover the basic use of that. So therefore I've prepared here this code snippet. So this class here where we create here this instance attributes. And now let's use this deleteAttribute function to delete here this x attribute. So therefore then we simply say deleteAttribute, and again we pass in first our instance and then the respective attribute that we want to delete. So in our case that would be then x. So now if I run this and then try to access the x, then you can see that we get here an attribute error because attribute x doesn't exist. So using this deleteAttribute function is basically the same as using this delete keyword. So if we say here delete instance of y, then we also can delete that. And then if I try to access the y, then you can also see that we get here an attribute error because y doesn't exist. So this is how this deleteAttribute function works when the attribute exists. So now let's see what happens when the attribute doesn't exist. So therefore let's simply run here this cell again because x doesn't exist anymore. So now if I run this again, then we also get here an attribute error. And in contrast to this getAttribute function, here we can't actually specify a default value that this function should return in case the attribute doesn't exist. So in that sense, it's really the same as, or it's really equivalent to this del keyword, because if I run this for an attribute that doesn't exist, then we also get here an attribute error. So that's the basic use of this deleteAttribute function. And then here, next I want to cover a potential use case. So therefore, I've again prepared here a code snippet. So let me paste that. So here we do the same thing. We create this my class and have these two instance attributes. And then now let's say that we want to delete all of these attributes here with a code instead of running here these their keywords manually. So therefore then we can simply create here this attributes variable which contains a list with all of the attributes. Then we loop over those attributes and then simply use here this delete attribute function to delete all of these attributes. So now if I run this and then try to access X, then you can see that it doesn't exist anymore. And if I try to access Y, then you can also see that this doesn't exist anymore. So this is something here that you couldn't do with using here this del keyword. Okay, so those are my notes then for this delete attribute function, and this is how you can use it. And then lastly, here I have some additional functions listed that are still available, but that I'm not going to cover in more detail. So here there is class method, static method, property, super, and is subclass. Okay, so with that then, we've covered all the functions that I wanted to cover with respect to this classes category. Then the next category is called object information, and this contains functions that provide some kind of information about the given Python object. And here, the first one is called type. So to demonstrate that, I've prepared here these 3 variables. So we have here x, y, and z. And now let's check the type of those variables. So therefore then we simply say here type of x. So this gives us then this int. So the type of x is an integer. Then next, let's check the type of y. So this is a string. And then lastly, let's also check the type of z. And then here we can see that this is a list. So this is how this type function works. Then the next function is called id. And the purpose of that is to check at what place in memory a certain variable is pointing at. And this is important to know for mutable objects. And we've talked about mutability in another video. So if you don't know what that is, then I will put a link to that video into the video description. But now let me just show here what this id function is useful for. So therefore I've prepared here this code snippet. So here we say set a equal to this list, then we say here b equals a, and then we say c equals a dot copy. So now if we print out those variables, so if we say print a, and then also print b and c, then you can see that they all look the same. However, if I now print out here the IDs, so if I say print ID of a, and then also the same for b and c, then you can see that a and b have the same ID, and C has here a different ID. And here I also provided an illustration to demonstrate here what's going on. So let's have a look at that. Namely, what happens is the following. So when we say a equals this list, then this list here is created, stored in a specific place in memory, and then a points at that specific place in memory. And then when we say here b equals a, then we say that b should point at whatever a is currently pointing at. So it's also pointing here at the same place here in memory. So therefore then we get here the same IDs. And then lastly, when we say here c equals the copy of a, what then happens is that we create a copy of this list here. This is then stored in a different location in memory, and then c points at that different location. So therefore then we get here this different ID. Okay, so that is how this here ID function works. And then the last function is called hash. And here the first note is a definition. Namely, a hash is a fixed sized integer that identifies a particular value. So to show that, let's use here this function. So we're going to say hash, and then here we provide a string that says hello. So if I run this, then we get here this particular hash. However, if I now here do the same thing, but only with a capital H, then we get here a different hash, and that's because this is here is a different value than this hello here with a lowercase h. Okay, so that's the first note. Then the second note states that all of Python's built-in immutable objects are hashable, and therefore then all mutable objects are unhashable. So for example, to show that, let's try to get here the hash for a list. If I run this like this, then we get here a type error because we have this unhashable type list. The same thing also happens for a dictionary, and the same thing also happens for a set. So here the set is also unhashable. So that's the second note. And then the third note states here that if different variables have the same hash, then they necessarily have the same actual value, but they don't necessarily point at the same object or place in memory. So to demonstrate that, I've prepared here this code snippet. So here we set a equal to this tuple, then we say b equals a, and then we say here again c equals also the tuple containing 1, 2, and 3. So now if I print out all of these variables, so if I say print a and b and c, then you can see they all have the same value. So therefore they necessarily have to have the same hash. So therefore then if I say here print hash of a and then also of b and c, then you can see they all have the same hash. However, they don't necessarily have to have the same ID. So then if I say here print ID of a and then also b and c, then you can see that a and b have the same ID, whereas c has a different ID. And here again, I have an illustration to show that. So let's look at that. So here what's happening is the following. So when we say a equals this tuple, then this tuple is created, stored in a specific place in memory, and then a points at that place in memory. And then when we say here b equals a, then b should simply point at whatever a is pointing at. So therefore it's also pointing at this place in memory, and therefore then here we get the same ID. And then here when we say c equals this tuple, which also contains the 1, 2, and 3, then c is not pointing at this tuple, but the new one is created and stored in a different place in memory, and then c points at that place in memory, and therefore then we get here a different ID. Okay, so this is then how this hash function works, and with that then we've covered here all the functions in this object information category. Then the next category is called scopes, and we will talk about scopes here in the next video. So therefore let me just show you what functions are available. Namely, we have here globals, and then here locals, vars, and dir. So the purpose of those is to check what variables are available in those different scopes. So to demonstrate that, I've prepared here this code snippet. So here in the global scope, we create your variable 1. And then here in the local scope of this function here, of this print namespace function, we create your variable 2. And then here I'm simply printing out the return values of all of these functions here. So now let's run this. And then here you can see for this locals function, we get here this output where we have this dictionary with variable 2 and the respective value is then hello. Then for this vars function, we get actually the same result here. And then here for this dir function, we get here this list, which contains only the name of the variable and not its value. And then here lastly for this globals function, we get here this dictionary, which contains all the variables in the local scope. And if I scroll here all the way to the right, then here we can see our variable 1, which has here value 1. Okay, so those are the available functions for this scopes category. And then the last category is called computer science. And here I've simply listed all the functions that I think are somewhat related to this computer science field, which is a more advanced topic. So I'm not going to cover these functions here in more detail. So therefore then we've now covered here all my notes with respect to the built-in functions in Python. So therefore then we've reached the end of this video. And then in the next video, we will go over my notes for the different scopes in Python. So thanks for watching, and hopefully I will see you in the next video.